My name is Dmitriy, and I'm a software engineer at Valor Software. At SAP, I've spent a fair amount of time working with fundamental NGX Angular component library, and today I want to focus on a topic around repository tooling and maintenance, and specifically talk about a Nrwl's technology called NX. It's been around for a while at this point, but I'm seeing that quite often people use only a small fraction of the tool chain that NX provides. So the goal of today's talk is to guide you through some concepts that might appear useful for your teams and projects. So in general, NX is a powerful build and workspace management tool with a specific mental model that allows you to architect, build, test, and deploy your projects at any scale or with the most popular modern front-end frameworks like Angular, React, or Next.js, for example, and backend ones as Nest.js, Express, or even with a plain JS without any frameworks at all. Also, it can bring a lot of value for small and mid-sized projects, and it starts to really shine when it comes to huge applications and monorepos. With more than 2 million weekly downloads, NX is widely used in various companies of different size, including Fortune 500, on a daily basis to empower their teams. Here at SAP, it's also used in various private and public projects. The bright example of the public one is what the guys before were talking, a fundamental NGX component library. And NX works with a few concepts to drive your monorepo efficiently and effectively. Today, we will look at them in detail and we'll try to understand how NX can simplify life for your teams. So first of all, let's talk about how NX structures your code. Generation of the repository is pretty simple. By running create NX workspace command with the name of the workspace, we will be prompted with a few questions like whether to generate a certain preset. It can be an Angular workspace, basically any front-end frameworks, back-end ones. Combination of those, like we can create a repo with Angular and Nest.js already set up for us, and it can be an empty workspace without anything, so you can start from scratch. Since we are choosing Angular here in this example, it will also ask for a few additional questions like an application name, what style sheet to use, and whether to enable distributed caching to make our CI faster. This guy is a pretty cool one, and we will talk about it a bit later today. So whenever we generate a repo, we will see the structure of the code that you can see on the right side of the slide. There are a lot of configurations file, and I want to focus exactly on apps and libs folders. So within apps, there is an actual app we generated, an awesome UI, and end-to-end tests for it as a separate application. The idea is then that under apps, we always put only the code that we need to bootstrap our applications. No matter how many apps you have, it can be 1 or 10, the apps folder should only contain the very minimum amount of logic that is needed to have your app bootstrapped and run successfully. And everything else goes under libs. This allows us to make all our code reusable between all applications, because, for example, if we have a few, all of them can grab whatever they need from libs. Also, we can build proper relationships between code libraries, because we can configure what library particular application can depend on. If we have a few, for example. And also, we'll be able to have a scalable structure of the repository with a set of optimizations that are done by NX and we will talk about them a bit later. So the easiest way to understand what the library is to generate one. Let's quickly add a simple utility library. We can use a generator, one of NX's generators that they provide for that. And once this is done, we will see an output conveniently in the console with what files were created, updated, or deleted. And the actual folder structure of the newly generated lib is on the right side of the slide. There are, again, some configuration files, and actual logic is under src lib folder. As you can see, there is a util we generated and end-to-end tests for it already set up for us by NX. So in a nutshell, a library is a kind of isolated project with a certain amount of logic that is related to the specifics of a particular lib. You may think of it as a building block for your application, and all further interactions should be done on top of that on the level of libraries. So they should kind of communicate via public API. Each NX library allows you to perform certain actions against itself. The basic example of such actions would be linting or testing. In other words, instead of running tests for the entire project, we can only run it for a particular library. And right now we are looking at the file within our generated library, which is called project.json. This file contains all configurations for the library it belongs to. And as you can see, the biggest part of it takes the targets object, where we actually have these configured actions to do something with your library. And each target has some set of options that are specific to that target. As you can see, they are different for these lint and test ones. And everything here works around the executor of a target. For example, for the test one, we are using a Nrwl jest executor, and as an option, there is a pass to the jest config file. So we can run our tests with this configuration. And this allows us to run an nrwl util format number :test command, and only tests that are related to this library will be executed. The task itself consists of a project, which is our library, and target, which is a test in our case. So it can be replaced with lint to run linting. And when we run it, as you see, only one test that belongs to this library is executed. So executor, again, it's basically a specific script that can perform actions on your code. NX comes with a variety of those for linting, building, testing, running Cypress, storybook, etc., etc., etc. And you can even run any external commands with executors. For example, let's configure our library to be polite and say hi before running its tests. This is done by using one of NX's executors called run commands. Its purpose is to run some bash commands, as its name tells, and we will print a short welcoming message and then run the test command we used in the previous slide. So when we do it, we will see it firstly welcomes us and then runs the tests as we saw before. Along with predefined executors, you can also define your own for any custom logic not covered by NX, but this is a topic for a separate discussion. An interesting feature about task executors is that their results are cacheable. NX knows when the task you are about to run has been executed before, so it can use the cache instead of running the actual task. And here is how it's done. Before running any task, Nix computes the computation hash. As long as the computation hash is the same, the output of running this task is obviously the same. And if Nix finds the computation, it retrieves and replaces it. It places the right files in the right folders and prints the terminal output. So our cached build command that you can see on the left will actually place artifacts in the dist folder. And from the user standpoint, the command ran the same, just a bit faster. You can see that I'm running it 2 times here, and firstly it takes 6 seconds to run, and the second time is only 29 milliseconds because it's instantly retrieved from cache. Nx attempts to consider every aspect of running a task to make sure the cache is valid. So by default, the computation cache includes all the source files of the library and its dependencies. So whenever any file within your lib has been changed, the computation hash will be different and you won't get cached results that are invalid. It also includes relevant global configuration versions of external dependencies, for example, from package.json, right? It also includes CLI command flags. So when you run build command with a production flag, it won't retrieve results of a dev build, obviously. And this behavior is highly customizable because you can configure Nx to accept some additional commands to be included in the hashing process. I mean, their outputs. It can be, for example, the version of the node you use. So whenever someone uses version 16 and then switches to 14th node, the cache won't be retrieved. By default, Nx uses a local computation cache. It stores the cached values on your machine for a week, and after that, they are deleted. Along with this, there is an ability to connect your project to NX Cloud and provide an ability to distribute the computation cache between multiple machines. And this allows CI agents, your team members, maybe some other tools to use this cache and not run the same tasks again and again. The way it works is basically instead of looking only for a local cache, it will firstly try to retrieve it locally, and if not found, we'll check for existence of this cache in the NX Cloud. If not found there, it will proceed running the task. And once the task succeeds, its results will be uploaded to NX Cloud for further usage. And with this, your coworker can execute the same command and save time by leveraging the cached results that were computed by you before. And actually, it works exactly as I'm saying. So let's say Tom executes the build command for an application, and it takes him like 5 minutes to do it. And after that, Jane wants to bootstrap the same application again. And when she runs the build command, it will take it only seconds because the results will be pulled from NX Cloud. And even more interesting is that the same cache is shared with CI agents. And just think about it. Usually, those CI agents run pretty much everything a regular developer will attempt to run on their local. So because of this, pretty much any code that you have pulled from master will execute instantly because it was computed before on the CI. Overall, the feature of running actions for each library apart gives us an ability to group libraries following a certain logic and run actions for them in a batch. Let's discuss another concept here that is called Dependency Graph. NX creates a graph of the dependencies between all projects and libraries in the repository. Here is how it looks for our repo right now. I have done one step behind the scenes and imported the util we generated into the actual application. And NX sees this connection. And overall, this is the structure of the repo we have at this moment. It's an actual app, our util, and end-to-end tests that are tied together. Let's stop here and introduce a few more libraries. Now, additionally to Awesome UI app, we also have an admin one, and we generated a few additional libraries. So a util format number we had has been moved to a shared folder, and for admin and Awesome UI applications, we have like 3 libraries to use. Again, behind the scenes, I have made a few imports. So like shared util is imported in the Awesome UI as it was before. And these guys are basically coupled together. You can follow these arrows to see what's happening. And actually, this is a good benefit of NX. Exploring the graph visually can be useful to understand why NX is behaving in a certain way and get the high-level overview of your code architecture with libraries. This is done very simple by running NX graph command, and you will have a new browser window with this scheme you see here. Dependencies are determined by TypeScript import statements that reference a particular library path. So as I said, I imported one library into another, into an application, and so on. And NX can track those imports. And also, they can be determined by manually specified so-called implicit dependencies in the project configuration file. Basically, implicit dependencies is a way to tell NX that library A depends on library B, even if NX cannot see any relations between these two. This is useful when we are dealing with styles, for example, because global CSS can definitely affect a certain library, and we cannot have NX to understand it. Or, for example, an Awesome UI end-to-ends depend on an actual application, and as you see, it depends implicitly because there is no actual connection between these two applications. Under the hood, NX uses Dependency Graph to compute how your change affected the whole repository. Looking at the graph, let's say we have changed Awesome UI models product library. And once that is done, basically, this library was affected by the change. And along with this, all libraries and applications that depend on it. So in our case, it's a models product, feature products, feature card, Awesome UI application itself, and end-to-end tests for it. And the cool thing that you don't have to manually track those arrows because NX has another feature called affected that can do it for us. So if we run NX affected dep graph command, we will see all these libraries conveniently highlighted in red for us. Same happens if we change a user management application in admin app. And for example, if we change a shared util, we will see that both apps are affected. In practice, this opens the door for us to be able to run actions only for affected libraries. Following the example on the previous slide, where we changed only this shared utility, we are actually able to run NX affected target test command And Nx will firstly determine the list of affected projects, pick those that are testable, because end-to-end apps are not testable. They don't have test target configured for them. And run those tasks. By the way, you can notice that I'm passing also a parallel flag, and this is quite convenient because this flag configures the number of parallel processes for our tasks to run. So basically, we are running three checks in parallel here, which is nice in terms of performance. And running affected checks allow us to significantly shorten the time needed for our CI to run, because instead of checking everything, we check only the required pieces that is absolutely necessary to check. Worth mentioning how exactly determination of affected target works. Affected command accepts two additional flags, base and head. They are defaulted to main and head respectively. Nx looks at the files that were changed in the repository between base and head Git revisions, and then determines what library each changed file belongs to. After that, all the magic with dependency graph happens, as we saw previously. It's widely used in the CI when, for example, you need to compare current revision with master for pull requests and compare the current revision with previous commit when you push something to master and run CI checks there. Another optimization technique Nx can offer is distributed task execution. While enabling computation caching with Nx Cloud helps us to reduce task execution time, distributed task execution helps to reduce the total time of your CI, I mean on parallelizing jobs that should be executed. So for it to work, you should define what tasks to run. It can, for example, be lint, test, and build, and basically your CI checks, right? And also how many agents you want to use for it. Then Nx Cloud Coordinator analyzes what tasks should be run and in what order. Basically, as we saw before, what affected tasks, it can understand it. And then tracks what agent has finished current task and sends the next one to it. So, for example, we have an agent 1 here that builds library A. Once it's done, coordinator will understand it and send, for example, lint library B to it, since it's free and this is the next upcoming task. So let's have a look at the scenario where we have to run 4 CI checks: build, lint, unit, and end-to-end tests. It's pretty common, right, to run these checks. There are a few ways how this can be done. The most straightforward and least efficient one is to simply run them one by one in a single worker. With this approach, in our case, it takes about 300 minutes for everything to complete. But usually it's never done like that in any big enough repo. And the easiest optimization here is to run all tasks in parallel, since they're independent. And in this case, the total duration is way better than in a sequential run. You can see in our mocked example, it's 300 minutes versus 100 for a parallel run. And this is usually how it's configured, at least in the most repos I saw. It's pretty nice, but in this case, we are limited by the duration of the longest running job. In our case, it's end-to-end tests with 100 minutes to run. So our CI will run as long as the end-to-end job does. But distributed task execution can drastically improve this setup, especially at scale. The key thing here is that it doesn't split your CI into jobs as in the parallel example. It splits the actual jobs. NX's orchestrator will go through each separate task in every job. For example, in the running end-to-end affected targets, and execute them in parallel on the free worker. I'm showing here that instead of 100 minutes for a parallel run, it will take only 10 minutes to complete with a distributed run. Of course, you won't see such an improvement with only 8 workers we have here in comparison to 4 in the parallel run. But we can use, for example, 20 workers here, and it really can take 10 minutes because everything will be split between these 20 workers, and all of them are fully utilized. And that's crucial here because distributed task execution allows you to scale your repository up to infinity, and once your CI gets slower, you can simply add another worker and get back to the small numbers in terms of time. Now I want to move away a bit from the topic of optimization and talk about how NX can help to structure an application. Previously, we discussed that NX architecture libraries, with NX architecture, libraries can become and should become the main building block of your app. So each of them serves a well-defined purpose. However, by partitioning libraries into these well-defined cohesive units, even with some medium-sized projects, you will end up having hundreds of these libs. And managing relationships between them can quickly become a chaos. In practice, a NX repo usually ends up with a structure of a few scopes. In our case, it's an awesome UI, an admin one, along with the shared scope, serving a purpose of any code that can be used by the previous 2 scopes. And if you visualize it on the graph, you will see that they are sort of vertically separated using these domains. And the way Awesome UI and admin can use this way, Awesome UI and admin can use code that we placed and shared, this util format number, but we would want to not have stuff that is placed in shared to be able to grab stuff from admin on Awesome UI applications, because it's like more context, right, than we need. So NX uses a tag system and dependencies tree, so you can enforce the dependencies flow you like across the projects and libraries. This is actually a property in the configuration of a library where you can describe the scope of the lib it depends on. So, for example, our feature control dashboards of an admin app has now the tags admin. And with this, we can go to the ESLint.JSON, the global configuration for ESLint, and set up the following constraints. So an Awesome UI application can only depend on Awesome UI and share it. Same for admin. And shared scope itself should only depend on itself and cannot import anything from other scopes. So whenever we do it, if we will try to import, let's say, an Awesome UI library into admin, we will see the linting error that will restrict this operation. With these constraints we have set, they will basically do the job, and the problem is that dividing the entire workspace with a few tags that represents these domains might not be enough, because each library should be quite specific in terms of what it does. As we said before, it's the main building block of your repository. So it should serve a well-defined purpose. And what we can do, along with splitting our logic vertically by scopes, is to also divide each domain horizontally into layers with the different types of libraries. This concept is described in the NX docs, and the suggestion is to categorize libraries into a few types. The feature type should be used for libraries that implement smart UIs with access to data sources. It can be your pages, for example, of an application, because they're like context aware. Data access lips should be used for code interaction with backend system. It can also include code that are related to state management, maybe retrieving stuff from local storage, basically to work with data. The UI libs, it applies only for the front-end applications, should contain presentational components that are also known as DOM components. So they should be like stateless, absolutely not aware of context, and so on and so forth. Utils should be low-level utils, maybe plain pure functions, some constants, and such kind of things that are used by many libraries and applications. And models to contain interfaces that are used, again, everywhere. With this, libraries of a certain type can depend only on libraries with the same type or the one below them. If you think about it, it completely makes sense, because, for example, DOM components should not have access to the data sources, or utils should not depend on your UI pages, for example. It doesn't make any sense. And with this setup, we can have our repository scale much better, and each library will be really understandable in terms of what it actually does. So at this time, we know that NX manages your repository on the level of libraries that can be treated as building blocks for your application. Most of your code should live inside of this dedicated, well-bounded libs. Each library can have different tasks to be executed against it directly. In example, listing, testing, or any other task you want using custom executors. This allows developers to work with each library separately up to a certain point. NX does an excellent job by caching the results of any task you run. So the second time you do it, it can be resolved instantly. Caching works locally or can be distributed between multiple machines with the help of NX Cloud. NX analyzes what your code has imported between libraries, and it tracks these connections and is able to visualize it on the graph. NX uses this graph also it uses it internally to determine how your changes affected the entire structure of libs, and it's able to get the list of these affected libraries and run tasks for them apart. So it's really efficient in terms of CI. NX can run checks on CI in parallel using different agents with distributed task execution. NX Cloud Orchestrator will distribute tasks between those agents efficiently so that all of them are fully utilized and your CI finishes as soon as possible. And I guess that's it.